So this is the 2015 Lch Higher Level Paper 2 and we're looking at question 7. A flat machine part consists of two circular ends attached to a plate, as shown in the diagram, which is not to scale. The sides of the plate, HK and PQ, are tangential to each circle. The larger circle has center A and radius 4 or centimeters. The smaller circle has center B and radius or centimeters. The length of HK is 8 or centimeters and the length of AB is 20 root 73 centimeters. So we have their diagram here, and the question says find or the radius of the smaller circle, and it gives us a hint and says draw BT parallel to KH, where T is an element of AH, so T will be a point on AH somewhere. Okay, so let's start by drawing that line. So B to T, so starting at B, I'm going to draw a line parallel to KH rather, so KH, going parallel to KH until we hit the line AH, and AAT is going to be on there somewhere, so there we go. So you can see there, that's parallel to this. I've drawn parallel and I've hit this point here, which I'm going to call T. So that's doing what the hint is telling me to do. Now if I do that, that gives me a right angle triangle in here as well. So if I'm looking for OR, in this right angle triangle here, ATB, so if you can see that, ATB, so there we go, we got T, A, and B, so I'm just drawing a sketch. This side, which would be the hypotenuse, is 20 root 73. Just try that a bit clearer. So 20 root 73 is this side. This side here is A to R, because it's going to be the same length as HK, because that's a rectangle there. And here, well, A to H is 4 OR, and because KB is OR, well, this HT will also be OR here. So if I want A to T, it's going to be 4 OR, the whole thing, minus this OR, which leaves me with this side being 3 OR. So now I have a right angle triangle. I have 3 sides, some of them in terms of OR, but I can do Pythagoras now and set up an equation. So 3 OR squared plus the 8 OR squared will be equal to the hypotenuse, 20 root 73 squared. Okay, so that gives me 3 OR squared. 3 OR by itself is 9 OR squared, plus 8 OR by itself is 64 OR squared. And then over here, 20 root 73 squared gives me 29,200. Okay, so 9 OR squared and 64 OR squared, that gives me 73 OR squared equals 29,200. So R squared will be 29,200 divided by 73, and that gives me an answer of 400. So if R squared is 400, that means that R will be the square root of 400, which is plus or minus 20, but because R is a distance, I'm also going to take the positive, so R is 20. So there we go, the radius is 20 centimeters. That's part A done. Part B says find the area of the quadrilateral ABKH. Okay, so if we go back to the diagram, ABKH is this quadrilateral here. Now that's already broken up into a thin rectangle and this triangle. So the rectangle is the area of the rectangle would be 8 or by or. So the rectangle equals 8 or times or, length by width. And the triangle would be half the base by the perpendicular height. So if I take the base to be 8 or, it's half of 8 or by the perpendicular height. Remember, that was 3 or. So it's half the base, half of 8 or by the perpendicular height, 3 or. So I'm going to add these two together then. So that gives me 8 or squared. And over here, half of 8 or is 4 or. 4 or by 3 or is 12 or squared. So when I add the two of them together, that gives me 20 or squared. And remember, or was 20, so it's 20 by 20 squared. So 20 by 20 squared, that gives me 8,000. So it's 8,000 centimeters squared for the area of the quadrilateral. Okay. Part C1 says find the size of the angle HAP in degrees, correct to one decimal place. So HAP. So H to A to P. So I'm looking for this angle here. Okay. Well, if I can find half of it first, so if I can find this shaded bit here, this angle there, well, if I find that, I can double it to find HAP. So I'm going to call this X degrees. So that shaded bit there is going to be X degrees. I'm going to double that once I find it. So if I look at the triangle ATB again, I know this side was 3 or, so 3 or was 3/20s, that's 60. And this bit here was 8 or, which is 8/20s, which is 160. So if I draw that triangle, it'll look like this. 160, 60, and I'm looking for X degrees. This was a right angle here. So I can say from this angle I have the opposite and the adjacent. So I can say that the tan of the angle X is the opposite, 160, over the adjacent, which is 60. So that means X is the inverse tan, hit the shift button, of 160 over 60. So that gives me a value of 69.44, and on it goes. So remember, I have to double that because that's X. So if I want HAP, I'm going to double that. So 2X will be 138.88, and on it goes. But I only want it to correct to one decimal place. So I'm going to look to the second digit after the decimal. So it's going to be 138.9 degrees. That's my angle HAP, 138.9 degrees. Okay, finally, part 2. Find the area of the machine part correct to the nearest centimeter squared. So the area of the whole machine part. Okay. Well, I can think about this in a few different sections. So I'm just going to use my highlighter to show you here. I know the area of this quadrilateral, that's 8,000. And I know that this quadrilateral here will be the same. So I've got two 8,000s there. So then all I need to do is find the area of this sector and the area of this little sector here. So this sector and this sector down here. So 4 different sections. So Remember, I know this angle in here now, HAP, so that means I'll be able to find this angle on the other side by subtracting HAP from 360. So let's do that first. HAP was 138.9. Okay, so if I subtract 138.9 from 360, that leaves me with 360 minus 138.9. That leaves me with this angle here, which is 221.1 degrees. Okay, so for this sector here, I can use the formula for the area of a circle, pi r squared, but it's not going to be a full circle. It's going to be 221.1 degrees out of 360. So let's get that much done. So I'm going to have the two 8,000s. So that's for the two quadrilaterals. The two quads is 2 by 8,000. For the big sector that I just looked at there, it's going to be 221.1 out of 360, that fraction of a circle, which will be pi by the radius squared. So what is the radius of that big circle? The radius of that big circle is 4 or, and or was 20, so that's going to be 80. So then I'm going to look at the small sector. So the small sector down here now, the angle HAP, which I know, is going to be the same as the angle KBQ, because KB and HA are parallel. So that angle there is actually going to be the 138.9 as well, 138.9 degrees. So if I want this small sector here, it's going to be 138.9 out of 360 by pi or squared, and or radius of this circle is 20. So that's going to be 138.9 out of 360 by pi by the radius 20 squared. So they're my different areas, and I'm going to work them out and add them together. And it's going to be correct to the nearest centimetre squared. So 2 8,000s, that's 16,000. This one here, when I put this into my calculator, that's going to give me 8.55. And this one down here on my calculator, when I work it out, gives me 484.85. So finally then, I'm going to add all of these together, and that's going to give me 2,883.4, and on it goes. But I only need to correct to the nearest centimetre squared. So that's going to be 2,883, because this 4 doesn't affect the 3 in front. So 28,833 centimetres squared for the area of the machine part. And that's the end of part C and the end of question 7.